Hello, thank you for joining today. You are most likely here because you are interested in observability for Kubernetes. Both of them can be complex topics on their own, and we put them together and it's even more complex. I'm Melody Hazi. I'm a senior solutions architect at Spectro Cloud, and I will be doing your presentation today. A couple of housekeeping items. We will be recording this webinar and it will be available on demand. If you have any questions today, put them in the chat and I will try to get to them at the end if we don't cover them during our talk today. So just a little high-level agenda. There's probably been a lot about what is observability and why it's important to Kubernetes, but we kind of have to level set there and at least start there and at least get my take on it before we can move to some of the other things about how can Palette help you. So we're going to talk a little bit about how Kubernetes observability requirements are different, things to consider in planning, right? And it's not just the technology, but a lot of people and process as well. We're going to touch on some of the different tools and solutions for Kubernetes observability, and then how Palette can help with that. How can we make it easy to get observability up and running? As well as a demo of that at the end. So jumping in, a little bit of background about me. You're probably wondering, Spectro Cloud is not an observability company. What are my chops for being able to speak about this? So actually, previous to working here, I spent 6 years at Signal Effects that got acquired by Splunk and became Splunk Observability. Signal Effects, or Splunk Observability, was one of the first observability tools built specifically for modern, large-scale distributed microservices-based systems with founders that came from places like Facebook, right? They knew they needed something different than traditional monitoring. So I have kind of that in my background, a little bit of other things of interest. I worked with the founders of Spectro Cloud previously at Clicker, which was another startup of theirs, so I really believe in their vision. My background was I was a server admin back in the day, 20 plus years ago, used things like Nagios, right? So been kind of in that monitoring space for a long time. I also spent a long time at VMware. And what was interesting is much like in VMware, there was a tipping point when production workloads started to be used on virtualization. We're kind of at that same time now with Kubernetes and containers where they've been around for a while, but we weren't really seeing outside of some cloud native companies, a lot of production workloads there, but we are now. So I think that's a bit relevant as well. When I'm not working, I like to be outdoors and not working in front of a computer screen. So what is observability and why does it matter? And so, it's to determine what apps and infrastructure are performing as expected, right? And then we want to help define what's expected. And this is one of the things that's kind of different from monitoring. What should this look like? What does it look like on a Friday versus a Monday or a holiday versus a non-holiday, right? The other is near real-time visibility, right? Traditional monitoring wasn't necessarily real-time, but observability is, right? Today in everybody's world, we want our food ordered quickly. We want our Uber to arrive quickly. Everything is very quick. And so you need real time to keep up with that. And to give teams actionable insights to make sure that they can improve not only availability and performance, security. And the big ones, right? You've probably heard of MTTR, mean time to resolution, right? So in the scheme of things, you want to reduce that time from about an issue, an incident, to when it's resolved. And then after the fact, even though it's resolved, help with that root cause analysis, like, really where is the problem coming from? And so kind of what are those differences? Why is it observability and not monitoring, right? So, monitoring is kind of telling you something occurred, like my CPU got too high. With observability, the goal is you had an error in application, but also what caused that error. It was a code push, for example. The monitoring kind of monitored against known issues and thresholds. You had to set that. I know that, something's wrong when my CPU is too high or my available memory is too low, right? Observability, we've advanced, right? And we can use AI and ML, and we can kind of monitor for the unknown unknowns, right? These are complex systems. And, you now have thousands, some people have millions of containers versus thousands of servers. you can't like set thresholds for each different one, right? It's kind of your pets versus you have, livestock kind of thing. How do we monitor this larger thing as a whole? And so it looks for anomalies that we may not even know exist. And because of these things, monitoring was very reactive, right? We waited for storage to run low or CPU to be too high. And so it was very reactive. Observability, if done right, becomes very proactive. It's ideally going to start telling you, this looks different than normal. Something looks off, hopefully before the end user, whether that's internal or external, notices an issue. And so you can start seeing like, oh, wait, things aren't performing as well, and actually work to fix it before there's an issue. The other thing about monitoring is a lot of times pieces were very siloed and monitored separately. And the idea, one of the big things about observability is it's tying all those pieces together. It's your infrastructure plus your applications, front end, back end, and it's correlating them together, right? So you might see something going on like an error in your application, but then you can on the same page see metrics about the infrastructure it's running on. So see, is that error possibly caused by the infrastructure or is it caused somewhere in the application? And then it also was very kind of siloed and separate for teams. The idea of the observability is you really want a cross-functional single pane of glass. So, and it's not just for different teams. So like if everybody's doing a root cause analysis, everybody's looking at the same data. We're not looking at different data trying to solve the same problem, and try to make sure that that correlation, so the upstream, downstream dependencies for each app or infrastructure component, right? So it's a lot like monitoring, but we've made it better for the modern distributed microservices world where every company is a software company and everyone, expects data and apps to load instantly. And so why does Kubernetes need observability versus monitoring, right? So a big one is just there's a lot of components and dependencies, right? So Kubernetes itself is a microservice, right? There's an API server, there's the kubelet, there's the scheduler. So even in Kubernetes, to monitor that with a service, there's lots of moving parts, right, in that. Then you're actually putting your workloads on it. There's still infrastructure underneath, right? So there's a lot of components. You need to know, like, what's going on. The other thing is it's ephemeral and it's large scale, right? So I kind of touched on this, right? So these things change a lot faster. You used to put servers in your data center and they sat there for months, years, right? You might have had, 1,000 hosts today. That's not changing on a daily basis. In the container world, like an average Kubernetes container lasts a day, where if you start even doing function containers, they can last less than an hour, right? So in a large scale Kubernetes cluster, you could be spinning up 25,000 new pods an hour or spinning them down. So you're monitoring a lot more things. There's a lot more data that you're collecting metrics on. So the scale of the amount of data is now huge, and it's also changing very, very rapidly. So you need a system to back in that can keep up with this, right? And that it will catch something, like a Lambda only lasts an hour. This is why we have to be near real time. You also have near real-time application changes. Cloud native microservices, there's companies, I had a customer in fintech, right? They were basically pushing code to production constantly. You have to, if you're going to do that and to enable you to do that, you have to have that observability in real time as you're pushing code. So if anything starts to go slightly off, you immediately see it and can roll back those code changes, right? So you need to be able to keep up with the companies that truly have, reached CI/CD or continuous integration and development. So I kind of like this slide, right? And it kind of talks to what we're talking to. I found this tweet. We replaced a monolith with microservices so that every outage could be more like a murder mystery, right? So if you had a monolith and something went wrong, it's all kind of sitting on one server, right? And in microservices, we already talked about the underlying service that's running it is probably Kubernetes, which itself has multiple pieces, and then the app is in multiple pieces. So without observability, if you just have monitoring, it is like a murder mystery, and you have probably no idea what's causing your issue. So just kind of, right, monitoring was designed for the monolith. Observability builds on that, but is really needed for microservices. So a little bit on where are we today, right? And observability, or O11Y is abbreviated. Some people are there, and they're probably the only people that truly have observability today, right, is like this cloud native. They started with it, right? If you're a large enterprise that's been around for a long time, right, you probably still maybe aren't or have more VMs and traditional servers than Kubernetes, but you're starting to have Kubernetes and microservices, right? And so maybe you're starting to shift from monitoring to observability, right? There's a wide range of tools and distinct pros and cons, right? There's these tools that were built cloud native for those kind of workloads. You have more traditional monitoring tools that are, work well in the monoliths, but now support microservices. So there's these large differences in adoptions. And one of the things is observability over monitoring doesn't provide a ton of gains if you're still running a bunch of monoliths, right? It's going to cost more because you have this almost real-time system. You have the storage system designed for huge scale, that if maybe you're running more servers and VMs still, you're not getting that benefit of like distributed tracing, for example. If you have a monolith, it's not really interesting to look at a trace. If you have a microservice or application with 20 microservices, that trace is going to be a lot more interesting, right? So there's something, depending where you are on going to microservices, you might not be seeing the benefit of observability, but increased cost. And one thing that I think is really important is observability isn't an end state, but it's a continuous process. For you to get to that place where you are proactive, you constantly need to be tweaking and improving this, right? So one of the advantages of observability is we are using on the back end, right, more AI ML, right, where the system is learning what looks normal for you, right? So because normal looks different, an online retailer, their normal on a Black Friday or before Valentine's Day or Christmas is going to look way different than the average day of the week, right? I also had a customer that's a streaming company. They stream things like the Grammys. It's definitely not going to look the same on the day of the Grammys when they're just streaming Disney shows any other day of the week. It's all kinds of things, digital, grills, smart grills, right? Memorial Day, Labor Day, their data and their application is definitely not going to look like it looks other days, right? So we have part of observability is we understand what looks normal at that time as things are spinning up, changing, scaling. But kind of like we played with using ChatGPT to like ask some questions about, Palette. And the thing is, even that has to learn, right? We as humans, we'd ask a question, we'd let ChatGPT respond, and some of the responses were good, but we had to tell the system that was good, or some of them weren't good, right? And we needed to kind of review that and give it a little bit of human feedback. So even the AI ML could kind of learn and get better over time. So you don't just implement it or move over the things you have. As you start to learn things about your applications and your systems, maybe you did have an issue and you did a root cause analysis, change the process, tweak how things are set up. And so it's kind of this continuous thing to really get in a proactive state. It's not very static. Core tenets of observability, I'm going to kind of, the biggest piece, obviously, and what came from monitoring is metrics, right? It's those numeric values. There's just a lot more of them today, right? And they're generated by everything, every piece of infrastructure, every service, Kubernetes itself. Most applications, if you're buying commercial software, right, you're probably building in your own metrics into your own applications, right? So it's the biggest piece, or not the biggest term in terms of storage, but like the number of metrics is huge. And a lot of it, I think, touching on this, is you need to figure out what's important to you, because everything generates a ton of metrics, but doesn't mean that all of them are useful. So especially in things like Kubernetes, learning what is useful, because you'll have millions of different types of metrics. And if you try to look or understand all of them, it's not really going to help you. Logging is important, obviously been around as well. A lot of people do logging, right? And again, it's generated by default by most services and applications. And it's your black box, right? It records everything that happened. So there's a ton of data, but it's kind of raw or unstructured, right? Or can be, right? And versus like numerical data of metrics. So it's a lot harder to store and query, right? So it's slow. This is why it makes the black box on the plane. It has that full history. It's great once you've had that issue, your plane's crashed and you're going to figure out what went wrong so it doesn't happen again. But this is not giving you observability. This is not giving you near real time. This is not helping you, and issues, observability isn't just for things that are down, right? Just performance issues. A good example is, right, no matter what industry you're in, you have a website these days or an application, right? Bounce rate is a big thing. So basically, if your page or your application loads in about 2 seconds, you have a 9% chance of bounce rate, which means people leave waiting for it to load. Between 2 and 3 seconds, that bounce rate jumps to 40%, right? So you're losing revenue within a second of time. And that's not even an outage. You're having latency that goes from 2 to 3 seconds, and you have a 40% bounce rate, which is now revenue. So logging by itself is never going to be fast enough to help you with that, but obviously it's needed for root cause analysis. Also, right, you have certain logs that are security and compliance reasons, right, that need to be stored for long periods of time. Tracing. People are probably less familiar with tracing or distributed tracing. It's not as interesting. I kind of mentioned and I touched on that in a monolith because everything's staying within one box, one application. Where it becomes critical is you have these microservice distributed-based systems, right? Say you're that retailer and you're doing an online checkout. You could have up to 100 microservices actually behind that, right? So where you click payment as a service, there's a catalog that has availability, the checkout service, right? These are all separate microservices, and you have to understand how they interact. Microservices often also interact with external dependencies, things like a cloud-based authentication service, or a lot of websites use Google Ad Manager to put relevant ads on their website, right? These are external services that also can slow down your website or your application. So understanding how these all fit together is super critical in a microservices world, right? We want to keep it so it's not a murder mystery. The other interesting thing, in a way, tracing is a little bit a mix of metrics and logs. In a way, a trace has a lot of data, so it's like a log, which can be expensive to store, but you can take the data off of traces and convert them to metrics, right? So specifically, you'll hear the term red metrics, which are request, errors, and duration, which are your kind of 3 critical metrics about applications that everybody's going to care about, right? So probably only developers are going to look at your traces and maybe some high-level support people. But those metrics, everyone up to execs are going to care about those. They're going to care about how many requests did we have? How many people did we have streaming today, right? How many errors did we have? Are those going down month over month, right? So those things become important to everyone. Another piece that is kind of important maybe when you're picking an observability tool is events. And people don't think of these as much because they're in a way an annotation. They're not actually telemetry. So they are an idea of a point-in-time action that can provide context to behavior you see in your observability data. So example is you did a code push, you did an upgrade, you started a maintenance window, you had a maintenance in time. So what you can do is you can correlate these if you have your time series kind of graph, right? So maybe you're looking at your latency or the number of requests or your error rate, right, in real time. And then you can correlate and you have these markers. You do a code push that shows up correlated in time on these graphs. So you can see, for example, you have a marker. At this time I did a code push. You see within the minute that the application latency starts going up. That's going to help give you context and tell you the first place I'm going to look is my code push. I probably had bad code that's causing that latency to go up. The other side of that is you can ignore abnormal behavior. So maybe you put a marker in an event that is maintenance starts now and a maintenance ends now. So maybe like you're not going to page people when, you know, services go up and down in that window, because guess what? You're doing maintenance. That's what happens. You have maintenance windows so you can take things down. One of the unicorn fintech companies I worked with, they are also the ones that push code multiple times a day. They will not push code, and if you're going to do that kind of pushing code, without looking at Splunk observability, and they had events were critical to them. So every time they pushed code, it was what environment, what microservice, and it went right onto these things that they're monitoring, like latency, error rate. So immediately they would know if there's any effects on the system. So really critical thing to kind of think about. There's also user experience data, synthetics and RUM. Synthetics are you're running a synthetic test to test the performance of your application. Can be from different locations, device types, browser types. RUM is the same type of data, but it's actual real user data, right? You're not keeping the user's information, but by say, maybe you're streaming the Grammys, you're keeping information about how many people are streaming from out west versus New York, things like that. Or, are they streaming on the phone or on a laptop? Is it a Mac or is it Windows, right? Both of them are actually types of metrics. You're getting metrics out of them. But why this data is useful is because it can help you pinpoint if you're using, say, distributed tracing and you see an issue with your application, is that issue possibly related to something outside your control? Wait, the error rate only applies, we're seeing this microservice with a bunch of errors, but wait, it's all in New York. It's probably with something with a network provider in New York, right? Or wait, our error rate on iPhones is way harder than on the desktop, right? So it's giving you additional information for troubleshooting. Another thing that's important to think about is visualization, right? How are you going to take this data, right? You're storing and collecting these metrics, these traces. How are you going to actually easily read and ingest and get insights out of the data, right? So you need a tool that has great visualization, that has the types of visualizations you need, right? Whether that's historic trends or like the other screenshot is, your distributed tracing, seeing how every piece fits together, right? So just to think about. Also, if you're an enterprise, you want to pick a solution that has to integrate, right? So most of the times you're not going to sit there and look at a screen all day, unless you are the developers at that fintech company that's pushing code constantly, right? Most people are not looking at dashboards all day long. The way they're getting notified is they're looking at dashboards when they get alerted that something looks abnormal. So you want to make sure that the system you pick, the alerting system, one, integrates with the things that you want to notify, because you're not necessarily paging people. You're sending things to Slack, or maybe you're opening a ticket in ServiceNow or Jira, or something in Salesforce, or you are using a tool like PagerDuty, right? So you want to make sure that it integrates easily with what you want. The other thing is on alerting is where the back end behind that, and it's usually like an analytics system, and where observability is different than monitoring and really important, is you want to make sure that it has those things where you can detect on not just, is my value higher than this? I want to detect that, hey, I'm a loan processing company. There's actually a bell curve to that. We process the most loans on Wednesday. Why does this look different than all my other Wednesdays? Is something wrong? Why is like the volume low today, right? So some kind of system that does this AI, ML, that helps you kind of find those unknown unknowns, historical anomalies. This looks different than what it normally does or than everything else in that population. So you want a system that can do that. And this is where that real time also comes into play. How long does it take from when the system sees there's something or that anomaly starts happening in the system till I actually get notified about it? And there's a lot of differences in the solutions you pick. So something just to be aware of. There's three main pieces kind of in the observability. There's define and instrument the telemetry to be collected. A lot of it, like metrics and logs, it's already defined. We just have to scrape it with something, which is piece two. If you are doing distributed tracing, that is where you do actually have to yourself instrument it, or your custom metrics for your applications that you write. The big piece in the middle is collecting all of that telemetry, right? Every application, every server, they expose metrics. But how do we collect those and send those to some kind of storage location and visualization solution? So that is your collector, usually in form of an agent, right? Some telemetry can be sent directly to a backend, but ideally you want to send it through this agent or this collector, because then you can do things. You can add context to that data. You can correlate data. So if you have traces coming in, you can correlate it to the infrastructure it's coming from. You can filter or obfuscate data, right? So maybe you are doing trace data, you have to take out PII data that might be in there. You can aggregate data. Many agents allow things to auto-discover, right? So we're talking about environments like Kubernetes, where things are going to automatically, whether it's pod or even the nodes under Kubernetes, are going to auto-scale up and auto-scale down. You want to make sure that your collection tool is automatically, you don't have to manually add something like you used to do in the day of Nagios, right? It's going to automatically pick those up, or maybe discover, you can just discovery rules in some of these tools where it will see, oh, this pod, look for common services like databases, message buses. And then if it picks that up, oh, we're going to scrape those metrics too. The third piece is your backend, right? So it's the UI for visualization, the alerting piece, which has the two pieces of both notifications and what's detecting anomalies, as well as just storing the data, right? And depending on the type of data, this is a big piece of the puzzle, right? There's certain data that you want to keep and probably compare year over year. You're an online retailer, you want to see your data, this Black Friday to last Black Friday. Are we doing better? Or maybe, you're just the loan processing company and you want to check month over month. Or, we're starting to get a lot of insurance companies, right? Like you just want to see that your performance, your error rate, your latency, the trends over time. And that's data that everyone cares about. Things like traces, full logs, they take up a lot of space. Do you need a year's worth of data? Do you need a year's worth of data for pods that are spinning up and spinning down and last a day? That data you probably don't want to store a year, right? So understanding kind of the storing the back end is really important. Another thing, this kind of more shows up in the UI, but you want to think about this, especially if you're the larger the company, the more this comes into play. What about access and permissions to data? Is there data that has to be isolated to a specific team? Maybe you are like the customer I'm actually on site today. They make point of sale software for restaurants. Software that they manage for customers is in multiple restaurant chains, right? So they probably want to implement observability for that, but then they have to isolate this data for their different restaurant chains, right? The ease of use for building those custom visualizations and alerts, every tool is different. So a lot of the tools, the commercial tools, they have out-of-the-box content. Even the open source ones do. Cardinality and scale. How much are you monitoring, right? Are you in the millions of containers? Because if you are somebody that is pushing those limits, for example, there's one of the original customers of SignalFX, a food review website, right? And they had millions at the time, right? Millions and millions of containers running, right? The real timeliness of your alerts. How important is it to you to get alerts within 5 seconds, or is 5 minutes okay? Depends on your business, what it's affecting. Are you losing millions of dollars per minute because you are a sneaker company and you're doing a shoe launch, right? And if your website's down when you're doing the shoe launch, you lose millions of dollars, per minute. So there, you probably care about those 5 seconds. You're another industry, the 5 minutes might be fine. The same with the dynamic and the AI ML-based alerting. Can the system learn what's system normal? Can they automatically detect a newly added systems and resources? So that's kind of the familiarity of it and things changing. So some considerations of the things we haven't talked about. The other things to think about are personas, right? And there's different personas that use observability data. We touched on this, right? So you have executives that look in and they care about those high-level metrics, right? Metrics that get turned in to your SLAs, things like that, right? Companies have SLAs, SLOs, SLIs, right? And the data that's running most of those things are those red metrics, right? Things like, error rate, latency, number of requests, how many people are using the software, as well as uptime, downtime, right? People all the way up the stack need that data. Are they going to look at trace data? No. So maybe if you're deploying, observability and you're kind of, building Kubernetes as a service for developers, you don't have execs looking at your observability data, right? It's inside and it's all developers. Developers are going to want things like full traces, right? So kind of really understanding who all is going to see it, right? So is there an enterprise level initiative? Are you possibly an enterprise platform architect, right? Because then it's for the whole enterprise. You might be thinking about all these personas and a way to address all of them, right? Also, how far along are you in that initiative? Do you still have a lot of VMs, right? And less Kubernetes. You need a tool that actually handles those. Obviously, cost comes into play for that, right? So who are you? Where are you, right? If you're a DevOps platform type person, right, you don't need to care about some of the personas. Cost, open source versus, bring your own or do it yourself versus enterprise software, right? You want to, a lot of companies, even big enterprises, right, you'd rather do open source because you're closer to innovation. But you probably need enterprise software for those things I said under UI considerations, like data isolation, large things at scale, right? Even at SignalFX, they won version 2 of handling that type of scale because they came and they did it at Facebook, right? So there's probably people that have solved that better than you. So unless you are a cloud native company and have a lot of resources, you're probably, if you're a big enterprise and you need those things, you probably are going to need enterprise software, even if you want to be close to open source. And if you are going to have to go that enterprise or commercial software route, you probably want to try to avoid vendor lock-in. So you want to do something that you put it in, you're not 100% stuck. Companies do come and go. They get acquired, change directions, right? So those are things to consider. Personas, we talked about it, right? So if you're more looking at from the enterprise level, things like long-term storage for compliance and historical trends, enterprise-grade features, multi-tenancy, RBAC, massive scale, single pane of glass for multiple teams. You're probably going to need to support, unless you're a cloud-native company, say you're a financial institution or an insurance company that's been around. You probably still have a lot more VMs, or you can, based on the customers I'm working with, versus Kubernetes. So it has to do both. To them, production systems often mean revenue generating. So they think of production systems as external customer facing only, right? You also need to be able to roll up that data for the 1,000-foot view for execs, right? For the high level systems. If you're down in the weeds, you're more Kubernetes, cloud platform team, DevOps, devs. Things can still be production to them that the enterprise team may not care about and be like, so if it's a Kubernetes as a service platform for your developers, if that's down, your developers are not being productive. So it may not be losing revenue, but you're losing money by productivity of your engineers, right? So to you guys, if you're, in more in that space, then it is still production to you. You're interested in all those low-level details, the full stack trace, the full distributed trace, right? You're probably definitely concerned about, optimize for microservices. You want ease of instrumentation. In some cases, you don't care about long-term storage, right? You don't care year over year about things. You're caring about my local code push. Do you need Kubernetes metrics when it's changing from a month ago? Probably not. You only need Kubernetes metrics for like 8 days. You may not need things like multi-tenancy, data isolation, and RBAC. They're just extra stuff. The stage of your journey, right? So we talked about this. Where are you? Do you have other things? Are you Kubernetes first? Are you not? Where are you? Obviously, cost. I think we talked about this. Long-term storage and support of real-time visibility at high-scale cardinality is expensive. So if you still have a lot of VMs, or why put things like Kubernetes metrics in long-term storage? Solutions that maybe split that data. Some of the stuff you want for developers in the weeds, like full traces, the ability to send that somewhere that it doesn't have long-term storage, right? what's important, right? Maybe there are two solutions for the enterprise level, because to them, production's one thing. But for developers, you really need something else. So there isn't always a one-size-fits-all. And then what skills and time does your team have to support and implement an observability solution? And this comes into play. So, that's where open source versus commercial solution comes into play. It is often actually cheaper to purchase the enterprise product. Good engineers are expensive, and it often takes multiple full-time engineers to try to maintain that enterprise functionality. Even if you're a big enterprise, we talked about this, you want to be open source first. And so select enterprise products that are built on open source technologies. Palette is an example of this product, right? If you're in the Kubernetes management space, we are a commercial product, and we're giving you those enterprise functionality, multi-tenancy, RBAC, et cetera, to deploy Kubernetes. But under the covers, we use Cluster API, which is an open source project, right? So basically, that is also used by other management tools. So we're not locking you in. You could leave that core functionality underneath it. And that helps with the vendor lock-in. And then obviously, if you're in a regulated industry, right, sometimes it's really hard to actually to even use open source solutions. You need an exception to it, right? Because there has to be some level of guaranteed production support, things like that. So just be aware of all these things. The observability tools, there's a few different ones. The most common is Prometheus, Grafana, and Alert Manager. It was the original Kubernetes observability. It's great in DevOps, right? But it's not a complete observability tool. One big drawback, it has no long-term storage. It's only metrics, no enterprise control, no support for large-scale centralized deployments, et cetera, right? So everybody hears about Prometheus, Grafana, Alert Manager. On the other hand, it's probably the most knowledge out there, right? There's wide adoption and community support for Prometheus, Grafana. An interesting space in the space of open source that then provides support is Grafana Labs. So Grafana was the original open source metrics dashboarding and visualization tool. Grafana Labs was built around that. And what they've done is they've now added additional open source functionality. They have three main ones. Miramar, which is your long-term storage, and that highly available for large-scale storage. So if you go a Prometheus Grafana route, you can put Miramar on the back end, and it's still open source. Loki and Tempo, which are for logs and distributed tracing. Then if you need a support model, so maybe you go the open source, but you get to a point where now your Kubernetes is running production workloads, external customer facing, et cetera. They have both on-prem and cloud offerings that give you support of basically, but under the covers, they're still using those open source projects. That's another thing to consider. Is how it is offered, right? If you are in some regulated industry, you probably can't use a multi-tenant SaaS. A lot of these enterprise leaders, that's where they are first. So that's something else to consider. These 5 that I put on the enterprise leaders are Gartner just had its new Magic Quadrant about observability and APM, and these are the 5 that sit in the quadrant. That's why I picked these 5. There's definitely more. The top 4 all started as kind of products for cloud-native distributed systems. New Relic was an APM solution that's been around longer, right? So it might be a little bit different because they added that functionality to better handle microservices and cloud-native as they grew because they've been around longer. Something that is very near and dear to my heart is OpenTelemetry. It's not a full observability solution. We kind of talked about the 3 parts. Your telemetry, that tool in the middle that collects, scrapes it in your back end. OpenTelemetry is that middle part. It is the collector. It's not a back end. It also can do instrumentation for distributed tracing. So it's actually kind of step 1 and step 2. It is an observability framework and toolkit that creates, correlates, and manages all forms of telemetry, your metrics, logs, and traces. It is open source, vendor, and tool agnostic. It is outside of Kubernetes, the second largest cloud-native cloud foundation project. For that, I talked about distributed tracing. It's the one thing you usually have to instrument. It has drop-in instrumentation. So you have a few lines of code, You drop it into your own code, and you'll have distributed tracing. What is amazing, it is supported and contributed by all those major leaders. So all the ones we talked about, the 5 in the Gartner Magic Quadrant, Grafana, others, Sumo Logic, App Dynamics. So even some of the more, maybe not leaders, maybe the tools like App Dynamics that was more for not cloud native, but does some cloud native, they also support OpenTelemetry. One of the other things is it supports multiple pipelines. So I talked about there's different requirements. You have developers that don't need long-term storage, but want like a lot of detail. Maybe they should be sent to one backend, but then you're a big enterprise, you have compliancy concerns, you care about year-over-year data for external-facing customer apps, and need long-term storage. So maybe you need a separate backend. With OpenTelemetry, you can support multiple pipelines. So you can collect data, and you can send that same data to different backends, or you can send different types of data to different backends. Or a subset of data, because they have these idea processors. So you know, maybe you filter out data that's really like customer-facing production, and that goes to 2 backends, both the developer backend that you choose, whatever tool works for them, and your enterprise Splunk observability Datadog solution. So it's really something that if you want to be, you know, have true flexibility, makes a lot of sense. So to sum it up, what is the best? It depends, right? The big thing is, I'm going to say, for kind of that instrumentation, the collection, go open source, right? Do something that's vendor agnostic, do OpenTelemetry, right? Like there's no reason almost not to, right? You may end up with multiple observability backends in your environment, right? Maybe on an enterprise level, they're still using more a monitoring tool, right? Because Kubernetes is not everywhere. It's in pockets in your large enterprise, right? But you're in one of those pockets where you're running Kubernetes. So you need observability for Kubernetes. So maybe you run Prometheus Grafana. Maybe you do it with OpenTelemetry as your collector, right? So then if they do go to observability, in the future, you can send your data to their observability backend, right? In most cases, avoid do it yourself. It's going to end up costing more. And then we didn't even talk about the problem if you do that yourself and you had these full-time engineers, if some of them leave and then you have to retrain people. So unless you are a really large cloud native company that can afford to hire the best of everyone, probably don't do it. For local scopes, you're starting out observability. Open source is easier. There's no reason not to start there. So with that, how does Palette help? So I'm going to jump in and do a demo. So give me just a second to share. So I'm going to log in, if I can find my mouse. Where's my mouse? Oh, sorry. I'm going to log into Palette. If you're here, hopefully you've already seen a demo of Spectro Cloud Platform Palette. And are somewhat familiar with the idea of cluster profiles. So cluster profiles, if you're not, are a way of declaratively defining what a Kubernetes cluster should look like, right? We define all of these layers, from the infrastructure layers to the applications on top, with the idea of what we call packs. And we have a bunch of what we call tier 1 packs, which are things that we support, we maintain, we keep up to date, like your OSs, your flavors of Kubernetes, et cetera. So here I have a pack or a profile for AKS, right? If you wanted to get up started, you're a developer, right? You wanted to start getting some visibility and some observability. I met this customer today. They've been a fairly small customer. They do ship logs out, but they have no other real-time observability, no dashboards or anything. What they could do to start getting that is add new pack. And if you go under monitoring at our public repo, you'll notice that we have kind of 4 packs that are related to Prometheus and Grafana. There's Prometheus Grafana, which would be the full package. It's going to be local to that cluster, which is how Prometheus Grafana was originally designed. It's going to have a Prometheus instance, a Grafana instance to visualize that. And all I could do if I wanted that is add that pack, pick the latest pack version, and basically I could not have to make any other changes. And this would, the only thing is I have to put in an admin password for Grafana. So I'm going to use a really, so I could add this to my profile and then go deploy this. And I would now immediately, once this deploys, have visibility into that cluster. So I'm going to leave out of this, and I already have this up and running. I believe it was my, not the AK's, wrong cluster, AWS demo, or Azure demo. I did this. Basically, I did a cluster on Azure, and I put in this Prometheus pack, no changes. It's actually going to expose the services, which is Grafana, Alert Manager, and the Prometheus backend. And if I go ahead and click this, it's going to take me to my instance of Grafana. The other pack that I added without any changes is Spectro Cloud Grafana dashboards. So this is out-of-the-box content. So we built some dashboards for you that's so relevant Kubernetes stuff, right? So it gives you a starting point. So if I actually go into Grafana and I go to dashboards, you'll see this folder Spectro Cloud, which is what the second pack's adding. And it's basically giving you these frameworks of easy-to-read dashboards, but some of the stuff that you would care about, like API server, right? And so without any other configuration, you now have local observability into that cluster with those out-of-the-box packs. The other kind of use case is maybe that's a lot of overhead. Every cluster you deploy, you don't necessarily want to run Prometheus and Grafana. So we also offer a way that you can have one cluster deployed with the observability stack of Prometheus Grafana. And then on all of the other clusters, you just put an agent, right? So this isn't going to be large scale, hundreds of clusters, but maybe you have 5 clusters or 3 clusters that you care about, right? You can run Prometheus Grafana stack on one and do an agent, right? So what I've done is we also do add-on profiles. So this could be really easy. So the Prometheus Grafana add-on is basically deploying that pack that I just did. And the only change that you have to make is under presets, which we do this out of the box. You have to go and enable that you want to enable remote monitoring. So that allows you to send data from other clusters to this instance. That's all you have to do. You could add this, deploy a cluster wherever you want, say EKS, AWS, Azure, on-prem. Add on this pack. It's going to deploy this as is, and you have to say, if you should enable remote monitoring, it's going to allow it to get data from other clusters. Then, for your other clusters, we also have another out-of-the-box pack called Prometheus Agent. And basically, I can add it as a layer. I don't have to make any changes to it, except once you've deployed your Prometheus Grafana stack, in here, you will actually put the URL for that, where you sent remote write. So if I actually search the URL, where is it? Basically, this is the URL, right? I launched this. This is an AWS where I launched my stack. And you can send remote data to that. So I've already deployed these on a couple clusters. So if I go in here, just so you can see that this works, right? So I basically did a Prometheus Grafana instance. I did just a basic stack, deployed these 2 things, but I allowed remote write, right? So I have my link to Prometheus Grafana here. I go back, and in this, I have another cluster that I deployed, and then I put the add-on pack of the agent, okay? So if I go into this instance of Grafana, and I go to look at some of those dashboards by cluster, not by cluster, I want to do it, trying to move fast. So if I go into some of these dashboards, right, we actually have stuff from both of the 2 instances. Why is this? Oh, I'm in general, sorry. I wanted to look at the Spectro Cloud. So the Spectro Cloud dashboards, you will see that on here we have data by the different clusters. So this Prometheus Grafana instance is data from itself. But if I wanted to see the ones for that other cluster, I now have it coming into here for Prometheus Agent. So if you're managing a few clusters and you're a developer, DevOps, this tool is awesome. And we have this out of the box today. This is the beginning of our start of observability journey. So one other thing that we don't have it as a tier 1 support yet, but I did do something. I went and I set up a cluster with OpenTelemetry. And what is really fun about this, if I go to my clusters, is I launched a cluster with OpenTelemetry demo. So it has a bunch of microservices on it, and it is instrumented with OpenTelemetry for distributed tracing. It has OpenTelemetry collector deployed on it as well. So first off, I exposed that service. So here's my microservices. It's called the OpenTelemetry demo, and it's go shopping, right? It's like a shopping cart demo app. So as part of that, I deployed, it's the same URL, you'll notice ends in 202. It also deployed Jaeger, which is actually an open source distributed tracing backend. You see it's the same IP. So it's in another container on there. And I can come in here and all these microservices that make this out, I can see this trace data from it. These are my distributed traces. I said, as I mentioned, you can do double pipelines. So I am sending that same data to an instance of Splunk Observability Cloud that I had a free trial set up. So if I go in here to this APM and I explore, I'm getting the exact same data. So I can go see add service. And I'm getting the same exact trace data in 2 different platforms. You might also notice this is your open source. This is the enterprise UI. You might be getting a lot more out of it, but maybe you're starting out, you're going to use this. But just with the tweak of OpenTelemetry, I can change it, and I could change where I'm sending this data. And in this case, I'm sending it 2 places. I've also done the same thing with metrics. I think we're running out of time. Where that basically I'm sending metrics to both Grafana and Splunk Observability. So we will be making a tier 1 pack for OpenTelemetry coming soon, ideally with presets for different environments. So to send to Splunk, you need something like an access token, your region, right? Depending what backend, there's certain data settings that need to be made in OpenTelemetry. And basically, we're going to have quick presets where you could basically say, I want to send it here, or I want to send my traces here, maybe metrics there. And we'll have presets for you so that you can, get the data to whatever enterprise solution you might already have. So anyways, that's the end of time. And since we've run out of time, if you have questions, we will get back to you individually. There is a lot of data in here. I look forward to hopefully doing another webinar in the future once we do have more out-of-the-box tier 1 support. You can actually do this today and build your own pack. I did this yesterday in a couple hours. Obviously, I'm familiar with OpenTelemetry. So if it's something, you're a customer of ours and we don't quite have, the presets for something you want, we can help build that for you. And it can be as easy to deploy as any other pack with our profiles. So back really quick on next steps. There's a blog. You can scan these codes on best practices for Kubernetes, observability at scale. There's also our docs, right? So those packs that we have today for Prometheus Grafana. There's documentation on all of those, how to deploy those. And obviously, we have a community Slack channel, so you can reach out there with questions. Our website has an announcement on it, or if you're interested in when, say, we're going to have a new pack in this observability space, check there or check Slack. Thank you guys so much for your time today. Sorry, we ran a little bit long. There's a lot to Kubernetes and observability. So next time we'll maybe try to focus on one area at a time. Thank you guys so much.